Hello, I'm Mrs. Dion. Today we're going to be discussing atoms. So what are atoms? Atoms are the basic building blocks of all matter. So every single thing in the entire universe is made out of atoms. Very, very basic unit. So we also have elements. Elements are structures that are made of just one type of atom. For example, gold. If you had something that's made out of gold, it's just gold. There's nothing else mixed in with it. It's one type of atom. And there are about 116 different elements. Kind of varies a little because sometimes there's man-made elements, and they actually are constantly making new man-made elements. Here's our periodic table of elements. This one does go up to 116. So these are all of the different things that our universe is created and made out of. So just putting these structures together in different combinations creates everything that we have in our entire universe. Since we are discussing biology, there's 4 main elements that make up all living things. These actually make up 96% of all living things. And there's really only 4. We have carbon, hydrogen, oxygen, and nitrogen. There are going to be some other trace elements as well, but these 4 together make up 96% of all life. So let's get into the atom a little bit more, the actual structure of what an atom looks like. So in the atom, we have a nucleus. The nucleus is the center of the atom, and that's the heaviest part of the atom. It's 99.9% of the atom's mass. So it's a very, very small but a very densely packed structure. Inside of the nucleus, you have 2, they're called subatomic particles, protons and neutrons. Protons have a positive charge, and neutrons have a neutral charge or no charge. Outside of the nucleus, you also have a space called the electron cloud, and there's some very, very, very small subatomic particles called electrons, which are negatively charged, and they are found there. And the atom is actually a lot of empty space. It's kind of like if the nucleus was a marble, it'd be like placing the marble in the middle of a football field, and then there's a lot of kind of empty space around that. So there's a lot of empty space within the atom. Talking still about the electron cloud, the electrons actually have a basic way that they will be organized. So we're just going to discuss the first 3 levels of how the electrons would be organized inside of the atomic structure. So inside the first energy level, they'll call it, you can fit 2 electrons. Inside the second level, 8 electrons. And inside the third level, 8 electrons. And those levels would fill in from the first level going out. So you need to put a maximum of 2 electrons in the first level, then you move on to the second level, fill that one up, and then go to the third level. Just showing you a basic model of the atom. This would be the nucleus, and this would represent where the electrons would be, 2 in the first, 8 in the second, 8 in the third. Another model of the atom, this one actually showing these positively charged protons. The neutrons are in the purple here. They don't have anything written on them because they have no charge. And then the negatively charged electrons outside of the nucleus. We also have something called the atomic number. This you're going to find when you look on your periodic table. The atomic number is actually a good way to identify atoms because it's the same number as the protons and electrons if we're talking about a neutrally charged atom, not an atom that has become positive or negative. So for our purposes, it will be the same as the protons and electrons. Each element will have a different atomic number. In the periodic table, when we look up element number 6, it's always carbon because that's its atomic number. Speaking of carbon, this is just showing you, if you look up on your periodic table, this is what you would see. This 6 represents the atomic number, and by just looking at that, we can tell that carbon also has 6 protons and 6 electrons because of the atomic number, and those numbers are all the same. We can see the symbol, which is C, the name, carbon, and then the atomic weight or atomic mass, which is how heavy the atom is 12.01. So the mass number, or the atomic number that we just saw in the last slide, is a measurement of how heavy the atom is. For our purposes, we are just going to figure this by adding the protons and the neutrons to get that mass number. If you remember in the previous slides, we had said that most of the mass of an atom is located in the nucleus. That's why we're adding up the two subatomic particles found in the nucleus to get the mass number. Our mass number will come out to an even number. Sometimes you'll see the mass number represented as a decimal, and what they're doing is averaging different isotopes of that element. But for our purposes, we're going to be adding the protons and neutrons, and you'll get a whole number. Speaking of isotopes, isotopes are basically, it's the same type of element, so you'll have one type of atom, but what can happen sometimes is that there's different forms of that atom where they'll have different numbers of neutrons. So the protons are always the same because carbon always has 6 protons, for example. That's what makes it carbon, but it can have different numbers of neutrons. So I'll show you an example of this. What we have here are 2 different forms of carbon. Over here on this one, the red represents the protons, and this one will have 6 protons. Again, on this one over here, there's 6 red balls represented here that represent 6 protons. That's what makes this carbon. But the white balls here are representing the neutrons. And if you added up or counted the white, there's actually 8 neutrons in this one. And if you count them here, there's 6 neutrons. So this one has 8 neutrons, that one has 6, but they're still both carbon. That's what makes them isotopes. And so this one is actually going to be heavier. That's why it has the 14 here. That's the mass number, because it has more neutrons that have weight. This one, the mass number is 12 because you're adding 6 protons plus 6 neutrons to give that 12. So really isotopes, you can consider them 2 ways. You can say they have different numbers of neutrons, or you could say they have different mass numbers, and it's still really saying the same thing. And so sometimes we represent it like this, where 6 represents the atomic number, and then 12 represents the mass number. But they're still both carbon, just different forms of it. And this concludes our presentation on atoms.